I think old people just lecture a lot. Alrighty. Okay, so I'm going to show you why the product rule exists. I showed you that if you try to do the shortcut, and okay, here's, and I know you got something on the margin. I'm going to write it on this margin. Voodooisms. And you know that's not a word. Okay, but there's a lot of things that, I mean, take a look. It's got 4 O's in it, right? How many words have that besides, I don't know, voodooism? Okay, so this is what I see a lot. That's wrong. You can't take the square root of a squared plus b squared and get a plus b. It doesn't work that way. You can't distribute the square root symbol. That is not true. Now, you can't do this. If I have a function and it's equal to the product of 2 functions, I can't say this. Those aren't the same. Now, it's not a voodooism. In May, it becomes a voodooism because you just learned this. This would make it really, really, really easy. In the example I use, is let's say that h is equal to x plus 3 times x plus 4. Now again, I would multiply that out, get x squared plus 7x plus 12, take the derivative and get 2x plus 7. That's the easiest way to do that. But you can do it using the product rule. And the product rule says, hey, keep this one, multiply by the derivative of this, plus keep this one and multiply by the derivative of this. Well, the derivative of this is 1 and the derivative of this is 1, correct? And if you did all that, you'd get 2x plus 7. But if you were a fine voodooist, you would simply say, hey, it's the derivative of this one, which is 1, and the derivative of this one is 1. That's got to be 1. Well, it can't be. The only way you can get a derivative of 1, it came from x plus something, right? Like x plus 3. That derivative would be 1. You have to come from a linear function that has a slope of 1. Does everybody see how I'm working backwards here? Well, what is this? This is quadratic, isn't it? And the derivative of any quadratic has got to be linear. It can't be a constant. Is that kind of making sense? Adam, I'm doing something wrong. What am I doing wrong? I mean, we want to do this. It'd be great if that worked because it's easy. It'd be great if that worked because it's easy. But easy is wrong most of the time, especially in math. But I'd rather take the derivative using the product rule rather than the limit definition. Okay. At least for now it's up on the board. Right behind Becca, kind of. All right, so here's the proof. And the proof, we have to use the limit process. So I'm going to start this, and I'm going to use h. So I got the limit. I got to make sure you see this okay. I get the limit as h goes to 0. And I have f of x plus h times g of x plus h. So I'm multiplying right here, minus their product. All over h. So we do a little algebra trick. We're going to add 0, because when you add 0, it does nothing. And so this is what 0 is going to look like. I'm going to put in f of x plus h g of x plus h. That's what I already have there. And I'm going to subtract f of x times g of x plus h. And I'm going to add it right in here. All over h. So I'm going to highlight it. I'm going to slide it over so you can see it a little bit better. So this part right here, I'll use red. Right here, these are just opposites. So all I really did here is insert opposites which are 0. So it doesn't change anything. Yes, ma'am? Because it's going to allow me to take the limit. Okay? And remember, I want to come up with this thing right here, correct? And what I'm going to have in here is the definition of the derivative of g and the definition of the derivative of f. Okay, and if you look at the definition of a derivative, one of the definitions is this. The limit as h goes to 0 of f of x plus h minus f of x over h is equal to the derivative of f of x. So I need that somehow. And if I want to know what the definition of the derivative of g is, I need to have this in here. That's the definition of the derivative of g. I need to somehow get those in there, and I don't have them in there. So what I do is I put something in there, and if you take a look at this, this might give me the derivative of g. Is that a good explanation? Okay. Yeah, it'll make more sense when we go on. Okay. And so I'm going to take the limit as h goes to 0. And what I'm going to do is, in these two terms right here, they both have g of x plus h. So I'm going to factor out a g of x plus h. And what will I have left here? I'll have f of x plus h. I'll have this minus, and I'll have f of x. And that's going to be over h. And what I'm going to do over on this side, if you look over here, I have a f of x, so I'm going to factor out an f of x, and that's going to give me g of x plus h minus g of x, and that's going to be over h. So I took this portion, brought it over to the left, and I took this portion and brought it over to the right, and separated them and made them two fractions. Okay? And right here I can say h is the same as 1 times h, and I could do that over here. So now I'm going to take their limits. I have 1, 2, 3, 4 things. Do you see that? And so I'm going to do it in, what's a different color? Purple. So now I'm going to take their limits. So on this next line, I'm not going to have a limit because I'm going to take the limit. And I can make h 0. So I can plug 0 into g, and I'm going to have x plus 0. So I'm going to have g of x. Times. Well, look at this thing right here. when I take the limit of this, isn't that the definition of this thing up here that I wrote? Oops, yeah, isn't it? So I can call this the derivative of f. And then I got a plus sign. X is not affected by h, so I'm going to have f of x. But what is this thing? This thing is my definition of g prime times g prime. And that's the product rule. Okay. So did we do 1, 2, and 3 in class? All right, I know the next is the quotient rule, but I'm going to give you a few just to see where you're at. Yes? This rate, I notice I'm taking the limit of this whole thing.
Well, yeah, but like in order to get it right, would you have to put limit like under?
No.
Okay.
For this pink part, no, because I'm taking the limit of this function, I'm taking the limit of this function, and since those limits are being multiplied, I got to keep the multiplication symbol. And then I'm taking the limit of that function, and I'm taking the limit of that function. So I'm examining each function as I take a limit, and what is my answer? Okay? So let's take a look at something like this. That's really where you're going to use the product rule. Does that make sense? If I can't multiply it out, it'd be easier to do the product rule, right? I have two functions. Nick, what's one of those functions? X to the third power. Allison, what's the other function? Sin x. I'm going to have to take the derivative of both of those, correct? And so my derivative looks like this. It's going to have a plus sign. Becca, what's going to be on the left side? Times what? Okay, you can't take the derivative of both of them at the same time. Okay, what's on the other side? That is correct. Now, let's say Alex did it and Alex did this. Let's see, she got that for an answer. Would I mark it wrong? Why not, Alex?
Because it's the same thing.
It's the same thing because math has commutativity, correct? We can put them in any order we want. Can we have this? Can you have that? Yeah, because multiplication has commutativity. We usually, because this can cause confusion, right? It kind of opens the door for doing some voodoo math. We usually write the coefficient and the polynomial first and the trig second. But you got to see that you got to have one derivative on one side of the plus sign and the other derivative on the other side. Does that make sense? Okay. I'm going to move on to the quotient rule. So what we're looking at is we're looking at a function, and I'm going to write it up here, in which we have what we call a rational function. Rational means it looks like a fraction. And we always have to put this in here, g of x cannot equal 0. And the rule is going to be this. This is the one that's in the denominator. You're going to square that. Now this is how you compute its derivative. You're going to square that. Whatever's in the denominator in your function, you're going to square the denominator, and then that's got to be the first thing you write in the numerator, times the derivative that exists in the numerator, minus the function that's in the numerator times the derivative of what's in the denominator. Now, unlike the product rule, you can't switch stuff around because subtraction does not have commutativity. 7 minus 4 is not the same as 4 minus 7. They're opposites, aren't they? So what I'm going to do is give you an example, and I'm going to write equals here. And so when I see a fraction, this is a function, this is a function, they are not constants, are they? If they were constants, I would treat them differently. A quadratic function in the denominator, a linear function in the numerator, right? My derivative is going to look like this. I'm going to use y prime. I do it in a particular order. I come down here and write x squared plus 1, and I write it squared, and here's the important part. Natalie, I don't multiply that out. I leave it like that. 1, it tells me far more information. 2, you might screw it up. 3, it takes time. I never mess with it. Then the next thing I do is I write x squared plus 1. Now, notice here's g of x squared, here's g of x, times the derivative of the numerator. Well, what's the derivative of 5x minus 2? It's 5, so it's times 5. Minus, where did that 5 come from? 5x minus 2 times the derivative of this thing. What's the derivative of x squared plus 1? 2x. So it looks like that. If you get to there, you got 0.7 out of 1. This is how you get the other 3/10. If you get to here, you have 0.8 out of 1. And now it's minus 5x squared plus 4x plus 5 over x squared plus 1 squared. And this is my final answer right here. I don't want you to mess around seeing if you can factor it. Just leave it like that. That's the quotient rule. And on the quiz, besides being on your notes, they're going to be up there. They'll probably be up there on the test too. Okay, I'm going to do the next one. So I'm going to write f of x, and I'm going to write this as 3 minus x to the negative 1 power over x plus 5. Are we okay with that? So this is going to be equal. Actually, I'm going to make it easier than this. No, I'm not. I'm going to do it like this. I got all of them written down. So down here, I'm going to have x plus 5 squared x plus 5. Now, why do I do it that way? Because Madeline, when I got to the quotient rule when I was in college, I screwed up on it all the time. So I said, okay, there's got to be a way that I can remember how to do this, and that this is the method that I remembered. You might create your own way. Times. Madeline, what's the derivative of this numerator right here? Okay, well, what's the derivative of 0? So then I'm going to take this negative 1, and there's a negative 1 right here. Would you agree with that? And so there's 1, and then what happens to this? Right, so I got x to the negative 2. Plus, I'm going to have 3 minus x to the negative 1 times, yes ma'am?
Why is that plus and not minus? Before the
Oh, right here?
yeah.
Because it was me thinking ahead and not watching what I was doing. And luckily, I have people that correct me. Or I made a mistake. You know, I used to say I was checking to see if anybody was paying attention. But now I know that's a lie. So I figured honesty. All right, Ethan, what's the derivative of x plus 5? 1. So, remember, if you get to here, you got 7/10 of a point. So now this is what I have. Let's see if everybody's okay with this. X plus 5 squared. And if this has an exponent of 1. Would you agree? So when I multiply, the bases are the same. I add the exponents. So can I say that's x to the negative 1 power plus 5x to the negative 2 power? Are we okay with that? Minus 3 plus x to the negative 1 power? Natalie? I got a minus here and a minus here. I'll make that a plus. Am I okay? Yeah. Okay. And that's the same as, well, here's 1x to the minus 1 power. Here's another 1x to the minus 1 power. So that's 2x to the minus 1 power plus 5x to the negative 2 power minus 3 over x plus 5 squared. This gives me 2 over x plus 5 over x squared minus 3 over 1 over x plus 5 squared. This means this should go to the denominator. This means this should go to the denominator. Morgan, what's my common denominator of these three fractions? Well, this doesn't have, it's the product of those three. Or, Okay, so if I asked you this, 3/4 plus 2/3, is one my common denominator? No. So my 1 is not my common denominator here. It's the common factor. What goes into x squared? Does x go into x squared? Does 1 go into x squared? So if this was 5, this was 25, and that is 1, wouldn't you say that 25 is my common denominator?
Yes.
Yeah, so it's x squared. Okay. So I have 2x plus 5 minus 3x squared over x squared over 5 plus, or excuse me, x plus 5 squared. Can I make that jump without losing everybody? So my final answer is this. A negative 3x squared plus 2x plus 5 over x squared times x plus 5 squared. Because I'm multiplying by the reciprocal, 1 over x plus 5 squared. Okay. Okay. It sucks a lot of energy out of you when you do that problem. That's go to a meeting and don't want to pay any attention, and I'm working on this problem question. Okay. Next page, I'll still do the proof in a little bit, so I'll come back to it. Okay, if you notice, I have up here what is the derivative of tangent, and I don't have anything written up there. So there is a gentleman, Tanner Voss, who is in, I don't know, maybe some of you know Tessa Voss, some of you may know Tanner Voss, some of you know Trevor Voss, and like a lot of families, they all started with the letter T. Okay? All of them did very well in calc. And Trevor went to University of North Dakota, and somebody said, the professor said, I'll show you how to do the proof of the derivative of tangent. And Trevor said, I know how to do that. And no one else in the class knew how to do it. And so what Trevor did, excuse me, what Tanner did, not Trevor, he says tangent is this. Right? I got a function on top, I got a function on the bottom. And so he did the quotient rule. Aaron, what's on the bottom when I take the derivative? And what I'm going to do with cosine, I'm going to do what? Square. And then right away, what's the first thing I write here? Cosine. What's the next thing I do? I take the derivative of what? What's the derivative of sine? Cosine. That's pretty nice. Minus the cosine of x, excuse me, the sine of x times the derivative of cosine, right? I have to take the derivative of this denominator. What's the derivative of that denominator? Negative sine. Okay? So you said write cosine on the bottom, square it. Come up here, write it right away. Took the derivative of the top, which is the derivative of sine, which is cosine, minus, not plus, right, Sophia? Minus. Then I've got sine times the derivative of that, that's a negative sine. So what do I have here? This is the derivative. This is cosine squared, correct? This is plus, because I got minus a negative, right? sine squared. Correct? Why are you smiling? Don't tell me yet. Okay. Down here I got cosine squared, right? That's how we write cosine times cosine. A lot of people think that's x squared. It's not. It means cosine times cosine. All right, now tell me why you're smiling, Allison. It equals 1. And this is cosine squared on the bottom. So what's my final answer? What is 1 over cosine? So it's secant squared x. So the derivative of tangent is secant squared. Derivative of tangent is secant squared. Do you have to do this every time? Nope. Do you have to have the derivative of sine as cosine? Yes. Do you have to have the derivative of cosine as negative sine? Yes. AP also expects you to know that the derivative of tangent is secant squared. But when you get old, Ethan, you'll be able to do this. Can you define old for me, Ethan? No. Give me an age. When is a person old?
60.
Okay. I was hoping you'd say like 90. Okay. Alrighty. So, Austin, f of x, we're going to figure out the derivative of cotangent. What do you suppose I'm going to do? Cosine over sine. Awesome. By the way, these are proofs. So you're going to figure out the derivative. What's going to be on the bottom? What do I do to sine? Square it. So can I write it as sine squared x? Are you okay with that? Then what's the first thing I write up here? Sine. Times the derivative of cosine. What's the derivative of cosine? Negative sine. And you said that so quickly. That's quite impressive. Minus. So now I'm going to have cosine, correct? Because we just took the derivative of that. That's right there. So now I got to take the derivative of this. What's the derivative of sine? Cosine. Again, you said that very quickly. So now I have the derivative equal to a negative sine squared x minus cosine squared x over sine squared x. Sorry about that. Now look to your right, Austin. Is Allison smiling?
Yes.
Are you sure that's a smile?
Smirk.
A smirk. Smirk. Does it give you confidence?
Very much so.
Okay, what do you think the next move would be?
Top to 1.
How does she get a negative 1? Well, I know sine squared plus cosine squared is equal to 1, right? Can you explain to me why this is a negative 1? Besides that Allison told you it was a negative 1 because she was smirking?
It equals 1 sine squared x minus cosine squared x equals 1.
I didn't quite hear what you said, so that's not your fault, that's my fault.
Multiply by negative 1.
Oh, if I go through and multiply by negative 1, it makes it all positive. Is that how you... Okay, I'll take that. Okay, that makes sense. So what is that, do you think, Austin? Well, it's got to be negative, right? Right, because there's a negative 1 there that you told me about? All right. right, Alex. See what you can do. What do you think I'm going to do on this one?
Turn secant into 1 over cosine.
Okay, so h prime equals, what are you going to get?
Cosine x on the top and the bottom. But on the bottom it's square.
Oh, can I just write it like this? I don't know. I didn't need parentheses. Sorry about that. Okay, times what?
Negative sine.
No. I got to multiply by the derivative of the numerator. I have to, which is what? 0. I'm going to make it look mean because it's going to do something in a bit. Minus 1 times the derivative of cosine, which is what? Negative sine. So what does this 0 do to that cosine? It annihilates it, right? It totally destroys it. Boom! It's gone, right? So now I have 0 minus a negative sign. What is 0 minus a negative sign? So I got sine of x over cosine squared x. Okay? Now, if I was the god of mathematics, I would leave it like that. But I'm not. I'm just a small wheel bearing in the entire machinery, okay? That squeaks every once in a while and people just throw oil on me, all right? So there's got to be a different name for that. Do you know what it is? Because they don't like fractions. As much as you guys don't like fractions, real mathematicians don't like them either, especially when it comes to trig. Want me to give you a hint?
Is it tangent x over times the secant?
That's exactly what it is. Now, you want to explain to people how your brain got there?
I factored the cosine squared at the bottom to cosine.
Like this?
Yeah.
And said, hey, sine of x is the same as that times 1. And I don't want to put words in your mouth, kind of like that.
That's kind
And then you said that's secant, and that's tangent. And that's what it's called. The derivative of secant is tangent secant, or secant tangent is the way that you see it most often. Because I don't know what it is about math people because they can't spell, but by God, does everything have to be in alphabetical order? We don't know how to spell it. We abbreviate everything. If we can't abbreviate it, we give it a letter or some type of fancy drawing like pi. Somebody said, hey, that looks pretty cool, right? You know, why didn't we go with a Greek letter for E? I don't know. Alrighty. Noah. What do you think your first step is to do with J? There's been kind of a pattern here. Look at number 5. How come you're wearing the Cyclone shirt today? Are you into maroon and gold? Is that it?
What?
Well, you wear a Minnesota shirt, which is maroon and gold. And now you're wearing a Cyclone shirt, which is maroon and gold. So are you going to have a Cobber shirt on tomorrow?
No.
Do you know who the Cobbers are?
Yeah.
Okay. So do you know how to rewrite cosecant? Really?
Not good.
Well, we need to be. Okay, I'm sorry, but that's the case. They expect that you know the reciprocal of cosecant. I'll give you a hint. It's not 1 over cosine. There, 1 over sine, that's it exactly. Okay, so somewhere along, you're going to have to put that in your notes. And then somewhere along the line, you're going to have to know that the reciprocal of cosine is 1 over secant. The reciprocal of sine is 1 over cosecant, and the reciprocal of tangent is 1 over cotangent. Because we're going to get to something later on that's really going to drive you nuts if you don't know those. All right? So now the derivative. What goes where, Noah? How on the bottom? Okay, and then what am I going to write up here? Times what? Yeah, y. Besides that, we see 0 right here and angry face. Where does 0 come from? Where did... Yeah, of what? No, derivative of sine is cosine. It's not 0. But the derivative... 1. Derivative of 1 is 0. Okay? Minus 1 times the derivative of sine. Cosine. Perfect. So now I have this. This is 0, right? This thing gets wiped out, obliterated, right? And I get 0 minus cosine. That's going to be a negative cosine of x. And we're going to do the same thing that Alex did. We're going to do this. So what is negative cosine over sine? Yeah, negative cotangent x times, what's 1 over sine of x? I forgot my x. Cosecant. And I think the book says a negative cosecant x, cotangent x.
That's not alphabetical.
Yeah, I know. I don't know why they broke the rule right here. I thought the same thing. Maybe it got past the... You know, sometimes stuff sneaks through. When, you know how you when you look at the back of the book, the answers are wrong? You ever have that happen? Okay, so I worked for a textbook company for 5 years, Holt Mifflin, and I wrote workbooks for them, and I made a lot of money. I couldn't believe how I made $10,000 in 3 months. I got paid $200 a page, and so I had an editor, and he said, yeah, can you have an answer key for all your work? I said, I thought you guys had people that would do that. He said, yeah, we used to hire college students. But they were so hungover from the night before that they'd always have the wrong answers. So once I heard that, I quit looking at the answer key. And I never even look. I don't ever have a key. I don't have any keys. I drive Mrs. Tamble. She says, how do you know whether they're right or not? They're all right here. Like when Josh said, where's your answer key? Well, you don't like where it is unless you can see into here, Josh. Okay, let's go back to the proof. This proof is very similar. So again, if you look at this, I somehow, Bryn, have to get the derivative of f in here and the derivative of g. So I'm going to put stuff into there, but they're going to be opposites. Now, I was told this, and I'm not a great science person. But I was told that certain acids and certain bases, both of which can be harmful to you, that when you put them together, you get salt. Is that true for the people that are in chemistry? Does anybody know that? Okay, well, I'll ask somebody who knows. I see Mr. Zaski every day, I'll ask him. But we're told chemically they're opposites. And so these are like, what I'm going to put in here are opposites, so it's like adding 0. So I got the limit. I'm going to use delta x this time, just to mess with you. And so what I have here is I have G, I have f of x plus delta x over g x plus delta x minus f of x over g of x, all of that over delta x. And I'm going to get a common denominator. And so I'm going to rewrite it like this. The limit as delta x goes to 0. And the common denominator is the product of these two denominators. Everybody okay with that? And so what I'm going to have is f of x plus delta x times g of x minus f of x times g of x plus delta x all over g of x times g of x plus delta x times, I'm going to multiply by the reciprocal, 1 over delta x. So I took this, multiplied by its reciprocal, I got a common denominator here. So now, I'm going to slide this over a tad. And I got the limit as delta x goes to 0. I'm going to write this. I'm going to write f of x plus delta x in parentheses times g of x minus f of x g of x plus f of x g of x. So there's my 0 right here. That's my 0. Minus f of x g of x plus delta x over delta x all over g of x plus delta x. So if I look at these first two terms, they both have g of x in them. So now I'm going to rewrite it like this. The limit as delta x goes to 0. I'm going to factor out a g of x, and I'm going to have f of x plus delta x minus f of x over g of x plus delta x times, I'm going to multiply this delta x over here times this fraction and get delta x. And on this one, I am going to factor out, right, plus, I'm going to factor out a negative f of x, and I'm going to have left g of x, a negative g of x, plus g of x plus delta x. And its denominator is going to be g of x, g of x plus delta x times delta x. So now I'm going to take the limit. So the first thing I'm going to take, what I'm going to do is I'm going to get a different color, and I'm going to use green, and I'm going to take and split them up in this fashion. So I'm going to take the derivative of, I'm going to take the limit as delta x goes to 0 of g of x. Well, delta x doesn't affect g of x at all, does it? So I got g of x. And down here, I'm going to have g of x, and when this delta x goes to 0, I'm going to have g of x, so I'm going to have g of x squared. Now, what is the limit of this? That's the definition of what? Derivative of what function? The derivative of f, correct? So this is going to be f prime of x. This plus a negative is going to be minus. And down here on the bottom, I'm going to separate this exactly the same way. So up here, I'm going to have f of x, and I'm going to have g of x squared for the same reason I did last time. Now, if you notice this, the negative is here, so I could switch them. I could write this, if I chose to, g of x plus delta x minus g of x over delta x. Again, that's the definition of the derivative of what? G. So I have g prime. And so the answer to this is going to be g of x times f prime of x minus f of x times g prime of x all over g of x squared. And that's the quotient rule. Okay, this you might do on a quiz. These back here, guarantee you that one of those or more than one of those is on a test. Okay? Because they're pretty straightforward. Alrighty. Higher order derivatives. Is that right? Alrighty, so here's how you can write the first derivative. Y prime, correct? And or I can write it dy over dx, correct? Or I can write it as f prime of x. Or I can write it as the derivative of f of x with respect to x. I think that's how it looks, kind of looks on your calculator, doesn't it? Right? And I think you put y1 in there yesterday. That's what that means. Or you could sometimes see it like this. Example. F of x equals x to the fourth. F prime of x equals 4x cubed. Well, the derivative of the derivative is called the second derivative. So if I take the derivative of this, I get the second derivative. We call that f double prime of x. So it's going to be 3 times 4, which is 12, x squared. I could call it y double prime. I can write it as f double prime. and you can see this on your calculator. I'll show you on this one. You don't have to get them out. Right here on my calculator, here's the first derivative, here's the second derivative. See where the 2's are? They look like exponents. It is not an exponent. It means you're going to take the derivative of the derivative. Does that make sense? It's going to tell us something. It's going to tell us something here in a second, if I ever get to it. So, another way to write this again, that does not mean you're squaring the derivative. It means you're taking the derivative of the derivative. Or it can look like this. Or it can look like this. Now, we have a thing called the third derivative. 3 tick marks, which means you're going to take the derivative of the second derivative, or the derivative of the derivative of the derivative, which in this case is 24x. Does it make sense why it's 24x? And that could be written as with 3 primes. I already talked about 3 primes. So now it looks like this, which is this, equals this. Sometimes, with the third derivative, they might do this, but they always do it with the fourth derivative. I don't like this, but that means you're figuring out the fourth derivative. It does not mean you're taking the function and raising it to the 4th power. And in this case, it's going to be 24. Does it make sense why it's 24? And so you're going to write this. You might see it like this. You will see it like this. You'll see it like this. I never write it this way because it just takes way too long to write like that. Okay? Now, what do you suppose the 5th derivative is of this? The 6th derivative. 7th derivative, 0. Okay? All polynomials eventually die. All polynomials eventually die. If I had something like this, what's the first derivative? Cosine x. Excellent. What's the second derivative? Excellent. What's the third derivative? Negative what? Yeah, negative. God, you're just holy buckets. I wish I would have been like you when I took calculus. What's the fourth derivative? Back to sine. It never dies. It goes on forever.